Okay, one-sided limits. Okay, the existence of limits x approaches a for the function fx depend on the behavior of f on both sides of a. Okay, if f approaches the same value as x approaches a from the left side and from the right side, then we say that limit of x approach a is exists. That means, okay, for limit actually we need to find the limit from the both side, which is from the left hand side. Okay, we denote it as x approaches a and we have a negative sign after the value a. This indicate that x approaches a from the left. Okay, and when we have x approaches a from the right, we put a positive sign after the value a. That's mean x is approaches a from the right side. Right, so for example, okay, if we have a function f here, okay, which is the function f here, and this is the graph, and we want to know the limits for a. Okay, if we look here, if we approach a, so a is here, this is a, and if we approach a from the left, so a and the left of a is here. So if we approach a, okay, from the left side of a, we can see that the function f is going toward the value 1. Okay, so that's mean for limit of x approaches a from left is 1. Okay, is 1. And when we approach a from the right, okay, from the right, okay, we can see the function is moved towards the value 3. So the limit of x approaches a from the right is 3. Right, so we have the different answer here. So if we need to do a conclusion about the limit of x approaches a, since from the left and the right are not the same, therefore the limit of x approaches a is not exist. All right, so that is for the first part of the question. So that's mean to limit exists, the limit from the left and right must be the same. Right, so here we look at example 4. Okay, we have a function here which is a function f, and this is the graph. Let's say this is the graph for the function f. Alright, so the question is we need from the graph, okay, we need to find the one-sided limit. Alright, so we have 3 question here, or actually 6. The first one is to determine the limit of x approaches 4 from the left and right, approaches negative 3 from the left and right, and also approaches 1 from left and right. So we can find the limit, okay, according by looking at the graph here. So first one is we need to find the limit of x approaches 4. So 4 is here. Okay, so the first one, when we tend or we approach 4 from the left, so 4 from the left, so that's mean is this graph we need to refer. So when x is approaches 4 from the left, you can see the function f is moving toward the value here, which is 2. So when x is approaches 4 from the left, okay, the function is going to move to 2. Right, so approaching 4 from the right, okay, we're going to see this function, the graph here. So it will move towards the value 3. Okay, so from the left 2 and from the right 3. Alright, so the b, limit of x approaches negative 3. So negative 3 is here. Right, so approaching negative 3 from the left, okay, we're going to see this function, this graph. So as x is approaches negative 3 from the left, you can see the graph is moving toward the value 1. Right, so the limit is 1 for approaches negative 3 from the left, and approaches negative 3 from the right. Okay, we're going to look to this graph here. So the graph will move toward the value 4. Right, so approaches negative 3 from the right is 4. Okay, next is x approaches 1 from the left. So 1 is here. Okay, this is 1. So approaches 1 from the left. Okay, from the left there are no graph here, so that's mean there are no limits here, so that may not exist. And approaches 1 from the right. Okay, 1 from the right, we're going to look to this graph. So when x is approaching 1 from the right, so the graph is moving toward the value 2, so the limit is 2. All right, so we can see, we can find the limit. Okay, one side of that limit.